A good afternoon to you all. So, my name is Walter Mamboza, and I'm going to be taking you for this module, Cyber Security and Forensics. So, today we just want to um, discuss some of the fundamentals of cybersecurity. So, we basically say cybersecurity is an action against cybercrime. But maybe to start, we'll need to have a clear understanding of what information security is. So, information security, according to Jim Anderson, Innovant, he defined information security as a well sense of assurance that the information risks and controls are in balance. Basically, what we're saying, risk in simple terms is the likelihood that something bad might happen. Then controls are countermeasures or techniques to ensure that our information is safeguarded. So the moment we talk about information security, we're basically saying there has to be some form of or a sense of assurance that the likelihood that something bad might happen and countermeasures to prevent that form what we call a balance. So that's information security according to Jim Anderson. But however, it is necessary to review the origins of this field and its impact on our understanding of information security today. So we're going to move on and discuss about the history of information security. So basically, information security began immediately after the first mainframes were developed, whereby there were groups that were developing code breaking computations during the World War II, and they created the first modern computers. And it was during this time that physical controls to limit access to sensitive military location to authorized personnel, and it was rudimentary in defending against physical theft, espionage, and sabotage. So in the 1960s, there was an organization known as APA, which means Advanced Research Project Agents. So it began to examine the feasibility of redundant network communication. And we basically were saying there was a guy known as Larry Roberts who actually developed the ARPANET from its inception. Then, from the 1970s and 80s, the ARPANET grew in popularity as did its potential for misuse. So fundamental problems with the ARPANET security were identified, which are there were no safety procedures for dial-up connections to the ARPANET, and there were non-existent user identification and authorization to the system. So, during the late 1970s, microprocessor expanded computing capabilities and the security threats also increased. So, information security began with the RAND report R609, a paper that stated the study of computer security. So the scope of computer security grew from physical security to include the safety of data, limiting unauthorized access to data, and involvement of personnel from multiple levels of the organization. So, Multics, there was an early focus of computer security research where a system called Multiplexed Information and Computing Service, that is Multics. So, the first operating system created with security as its primary goal. So the mainframe time-sharing OS developed in the mid-1960s by General Electric, Bell Labs, and Massachusetts Institute of Technology known as MIT. So there were several Multics key players that created Unix. So the primary purpose of Unix was a text processing. So during the 1990s, the networks of computers became more common, so too did the need to interconnect networks. So internet became the first manifestation of a global network of networks. In early internet deployments, security was treated as a low priority. So now, this brings us to the present, where we're basically saying the internet brings millions of computer networks into communication with each other, many of them unsecured. The ability to secure a computer's data influenced by the security of every computer to which it is connected. So basically, that's where we are in terms of information security, whereby we are basically saying, due to the interconnectivity of networks, we're basically saying uh, computers are networked, and once they're networked, you will find that the internet is a global village. There are several people who have different agendas. So we're basically saying the ability to secure a computer's data is influenced by the security of every computer to which it is connected. So if there are two or more computers that are connected together, and if there is no, and if they are not if they are not secure in terms of they don't have antiviruses, they don't have firewalls, they don't have intrusion detection systems, they don't have biometric systems. So it basically means the internet will not be a safe place. So some of you might be asking, what is security? So basically, security is simply the state of being secure or to be free from danger. The moment you are free from danger, then we say you are secure. So we're basically saying a successful organization should have multiple layers of security in place. An organization has to have physical security, personnel security, operation security, communication security, cyber security, network security, as well as information security. So, the protection of information and its critical elements, including systems and hardware that uses, stores, and transmit that information. That's what we are concerned about. So in security, we have what we call tools that are actually necessary for security. And such tools are policy, awareness, training, education, as well as technology. These tools are necessary to enforce security or to enforce information security. But however, with what we call the CIA triangle, which was a standard that is actually based on confidentiality, integrity, and availability. So, confidentiality, we're basically saying only authorized users should access certain pieces of information. And the moment we talk about integrity, we're basically saying data should not be altered or modified by unauthorized users. And then availability, where we're basically saying information should be availed to authorized users. So the CIA triangle was expanded into a list of what we call critical characteristics of so we have what we call components of information security. We have 5 basic components of information security, or let's say we have 4 basic components of information security. We have network security, computer and data security, and management of information security. So basically we are saying in network security, a network is simply an interconnection of 2 or more machines that are actually linked together. So we're basically saying when computers or machines are linked together, one has to ensure that that particular infrastructure is secured or that network is secured, because a network is the one that actually provides or is the one that is actually used by an attacker or an hacker to gain access to our systems. So network security is one component of information security. Then the second component of information security is management of information security. Basically, management is a process that involves planning, organizing, leading, as well as controlling. So you're basically saying management of information security, when you're managing information security, you have to plan for information security, you have to be organized for information security, you have to lead information security, as well as you have to control in information security. The third component of information security is computer and data security. So the computer has to be secure, as well as the information that is stored within the computer has to be secured. And as an information security specialist or as a cyber security specialist, you have to ensure that the computer as well as the data that is on the system is made to be secure. But last but not least, we have a very important component of information security known as policy. So, a policy is like an organizational law. A policy is the central or the main component that is used to secure or to make sure that all other components of information security are achieved. So, as cybersecurity specialists, we have to make sure that when we want to secure our information, we manage our information security, we provide computer and data security, we make sure that we have a security policy, and also secure our networks. So, with what we call the critical characteristics of information, we're basically saying the value of information comes from the characteristics it possesses. The value of information comes from the characteristics it possesses. So the first critical characteristic of information is availability. In availability, we're simply saying information should be made to be available to authorized users. I'll give you an example. Let's say, for instance, you want to perform or you want to access the internet and you've actually paid for that service. Let's say to your internet service provider, it might be Tel1, it might be Net1, it might be Zoll, etc. We're basically saying the service provider should ensure that that service is made available to you. Otherwise, the information will not have value in any way. So we're basically saying availability is a very important characteristic of information. Then accuracy. We're basically saying information should be definite. Information should be, so also on accuracy, it should be correct or precise. Then the next critical characteristic of information is authenticity. So when we talk about authenticity, we're basically saying information should be genuine or real. That's authenticity. Then confidentiality, we're basically saying only authorized users should access information. Integrity. If information has integrity, it simply means that information has not been tampered, has not been or altered in any form. That's data integrity. Then utility is simply the state of being useful or beneficial. We're basically saying information should be useful or beneficial to the intended user or to the intended stakeholder. Then position is simply having to control something or owning or having something. That's possession. So we have what we call the NTSI-SSC security model or the Makamba cube. So basically the NSTI-SSC security model or the Makamba cube is a three-dimensional cube, meaning it has it is a cube that has three sides. So this security model is what we call countermeasures, which are policy, education, as well as technology. It also has security goals, which are confidentiality, integrity, and availability. Then it also has information states, whereby we are saying information can be stored, can be processed, or can be transmitted. So when this model was created, we're basically saying in order to have confidentiality in our systems, we need to make use of technology such that information that is stored is kept safe. That's an example of the interpretation of this security model of the John Makamba or of the Makamba cube. Or we're basically saying in order to have data integrity, an organization has to make use of a security policy whereby data that is being transmitted is kept safe. So that's also another example of the Makamba cube. So we have what we call components of an information system. So we're basically saying an information system is an entire set of software, hardware, data, people, and network that is actually necessary to use information as a resource in the organization. So that's an information system. We're basically saying we view an information system as an entire set that involves the people, the software, the hardware, the data, and the network that is actually necessary for the use as a resource in an organization. So when securing components, a computer can be used either as a subject of an attack or as an object of an attack. So when the computer is used as a subject of an attack, we're basically saying the computer is used as an active tool to conduct an attack. And when a computer is used as an object of an attack, we're basically saying the computer is the entity that is being attacked. So on the slide is an example of where a computer is the subject and the object of an attack. On the other hand, we have a hacker that is using a computer as the subject of an attack. So basically the hacker is sending a request to a remote system that is the object of an attack. Then information is being stolen by the hacker through the use of the internet. So clearly this is an example whereby a computer can be used as a subject of an attack, or a computer can be an object of an attack. So there has to be a balance between information security and access. But however, we are saying it is actually impossible to obtain perfect security. Where we were saying it is a process and not an absolute. We're basically saying security should be considered balance between protection and availability. You will discover that some systems they have multiple levels of security, and sometimes uh, those levels or those layers of security will make it difficult for an authorized user to access certain pieces of information within that system. So we're basically saying there has to be a balance between protection and availability. So to achieve a balance, a level of security must allow reasonable access yet protect against threats. So in balancing information security and access, we basically have two users. The first user simply states that encrypting email is a hassle, whereby the second user is saying encrypting email slows me down. But however, the Chief Information Security Officer is saying encryption is needed to protect secrets of the organization. So in an organization, you need to strike a balance between security as well as access. And sometimes this can be done through educating users of the importance of information security. So we have what we call approaches to information security implementation. And we basically have two approaches. We have the bottom-up approach and the top-down approach. So we're going to start by explaining the bottom-up approach. So during the bottom-up approach, we're basically saying it is a grassroots effort, whereby we're saying system administrators attempt to improve security of their systems. The key advantage of this approach is we're basically saying we make use of the technical expertise of individual administrator. So sometimes it works as it lacks a number of critical features such as participant support as well as organizational staying power. Those are some of the disadvantages of the bottom-up approach. Then, in approach to information security implementation, we can have what we call the top-down approach. So basically, the top-down approach is initiated by upper management, whereby they issue policies, procedures, and process. They also dictate goals and expected outcomes of the project and determine accountability for each required action. The most successful also involves formal development strategy referred to as system development lifecycle. So basically, we are saying we have two approaches to information security implementation. You can either use the bottom up approach or the top down approach. So, is what we are saying when you use the top down approach, we're basically saying um, information or the strategies of employing security are implemented from the top, which is the CEO, going down to the security technician. But when you're using the bottom approach, we're basically saying the security tech are the ones that are actually developing strategies to secure our information within our system. So it's the security technicians that are actually initiating the security measures, and they are uh, carrying up or carrying upwards the strategies or the tactics to employ information security. So we have what we call the system development life cycle. The system development life cycle is a methodology for the design and implementation of information systems within an organization. And we're basically saying this methodology is a formal approach to problem solving based on structured sequence of procedures. So, using a methodology has its own advantages or benefits, such as it ensures a rigorous process and also avoids missing steps. So basically the goal is creating a comprehensive security posture or program. So traditionally, the software development lifecycle consists of 6 general phases. The first phase is the investigation phase, followed by the analysis phase, the logical design, the physical design, the implementation, as well as the maintenance and change. So in the system development lifecycle, we have what we call the waterfall model or the waterfall methodology. So as you can see from the PowerPoint presentation, the stages or the steps, they represent or diagrammatically represent a waterfall. So during the investigation stage, we're basically asking ourselves, what problem is the system being developed to solve? And at this stage, we're basically saying the objectives, the constraints, and the scope of the project are actually specified. And a preliminary cost-benefit analysis is also developed. At the end, a feasibility analysis is performed to assess the economic, the technical, and behavioral feasibilities of the process. So during the investigation process, we're basically saying we are trying to identify the problem. We also state the objectives and the constraints and the scopes of the project. We're also saying a cost-benefit analysis has to be done in order for us to actually see the feasibility of the system to be developed. After the investigation phase, we move on to the analysis phase. So analysis consists of assessments of the organization, status of the current system, and capabilities to support the proposed system. However, analysts determine what the new system is expected to do and how it will interact with the existing system. This process, however, actually ends with the documentation of the findings and an updated feasibility analysis. Then the logical design. Basically, the main factor is the business need. Applications are applications capable of providing needed services are selected. Data support and structures capable of providing the needed inputs are also identified. and technologies to implement physical solutions are determined. A feasibility analysis is also performed at the end. So, during the logical design, what drives us the most is the business need. And we're basically saying, is the application capable of providing the needed services is selected? That's the main factor that actually drives the logical design. Physical design. Technologies to support the alternatives identified and evaluated in the logical designs are selected. Components evaluated on make or buy decisions. Then we're also saying the feasibility analysis is also performed, an entire solution presented to the end users representatives for approval. Implementation. So during the implementation phase, the needed software is created, components ordered, received, assembled, as well as tested. You're basically saying users are trained and documentations are created. A feasibility analysis is also prepared and users presented with the system for performance review and acceptance testing. Last but not least, we have what we call the maintenance and change. So basically, this process consists of tasks that are necessary to support and modify a system for remainder of its useful life. Life cycle continues under the process, begins again from the investigation phase. When the current system can no longer support the organizational mission, a new project is implemented. So basically, those are the phases or stages that are involved during the system development life cycle when one is implementing the waterfall model or the waterfall methodology. So in information security, we also have what we call the security systems development life cycle. So basically, this security system development life cycle has the same phases used in the traditional software development life cycle, and it may be adapted to support specialized implementation of an information security project. But however, identification of specific threats and creating controls to counter them is done. So a security system development lifecycle is a coherent program rather than a series of random or seemingly unconnected actions. So the first process in the security system development lifecycle is the investigation process. So during this phase, we basically identify processes, outcomes, goals, and constraints of the project. And we're basically saying it begins with enterprise information security policy and an organizational feasibility analysis is performed. During analysis, documents from the investigation phase are studied. An analysis of the existing security policies or programs along with the documented current threats and associated controls are done. It also includes analysis of relevant legal issues that could impact design of the security solution. And it is during this phase whereby we're saying the risk management task begins. Logical design. So the logical design creates and develops blueprints for information security. Incident response actions are planned, whereby we're saying there is continuity planning, incident response, and disaster recovery plans. Feasibility analysis to determine whether the projects should be continued or outsourced is done during the logical design. So once we have a blueprint for the information security, we move on to the physical design. So needed security technology is evaluated and alternatives are generated and the final design is selected. At the end of the phase, feasibility study determines readiness of organizational for the project. During the implementation phase of the security system development lifecycle, security solutions are acquired, tested, implemented, and tested again. Personnel issues evaluated, specific training and educational programs conducted. Entire tested package is presented to management for final approval. Maintenance and change. Perhaps the most important phase given the ever-changing threat environment is the maintenance and change. Often, reparation and restoration of the information is a constant duel with an unseen adversary. Information security profile of an organization requires constant adaptation as new threats emerge and old threats evolve. So we now want to look at the security professionals and the organization. Wide range of professionals required to support a diverse information security program. So we're basically saying senior management is the key component. Also, additional administrative support and technical expertise are required to implement details of a successful information security program. So in summary, we're basically saying information security is a well-sense or a well-informed sense of assurance that the information risks and the controls are in balance. And computer security began immediately after the first mainframes were developed. And we're basically saying an organization has to have multiple layers of security in place, such as physical security, network security, operation security, information security, personnel security, cyber security, etc. Now that we have a clear understanding of what information security is, I think it is imperative for us to move to some of the elements of security, such as cyber security. But also, we're also saying security should be considered a balance between protection and availability. Information security must be managed similarly to any major systems implemented in an organization using a methodology like the security system development life cycle. And implementation of information security often described as a combination of art and science. So some of you might be wondering, what is cybersecurity? So cybersecurity refers to the technologies and processes designed to protect computers, networks, and data from unauthorized access, vulnerabilities, and attacks delivered via internet by cyber criminals. So, though cybersecurity is important for network, data, and application security, the moment you talk about cybersecurity, we're basically saying there has to be technologies and processes that are basically designed to protect the computers and the networks and the information that is stored there from unauthorized access, from vulnerabilities, from attacks. That's what cybersecurity is all about. The moment we talk about cybersecurity, we are basically trying to protect systems from cybercrime. So, what is cybercrime? So, some used to refer cybercrime as computer crime or computer-related crime or crime by a computer. With the pervasion of digital technology, some new terms like high technology or information age crime were added to the definition. Internet also brought other new terms like cybercrime and net crime, other forms of digital, electronic, or virtual IT or high-tech and technologically enabled crime. So that is cybercrime. So the history of cybercrime, we're basically saying the first recorded cybercrime was recorded in the year 1820, whereby the first spam email took place in 1978 when it was sent over the ARPANET, and the first virus was installed on an Apple computer in 1982. So cybercrime includes illegal access, illegal interception, system interference, data interference, misuse of devices, or fraud. So these are some of the forms or some of the cyber crimes that exist or that are present. Some of you might be asking yourselves, why should you care about cybersecurity or cybercrime? We're basically saying it is a criminal activity committed on the internet. That's why you should care. And in cybercrime, we're basically saying a computer is either a tool or a target or both. So how can we protect? We can make use of read privacy policy carefully when you submit the data through the internet. As a way of trying to protect yourselves from cybercrime, you should read privacy policy carefully when you submit the data through the internet. You should also provide encryption, whereby we're basically saying lots of websites use SSL or the secure socket layer to encrypt data. And we're also saying you should disable remote connectivity. So what are the advantages of cybersecurity? It will defend you from hacks and viruses. The application of cybersecurity used in our PC needs to be updated every week. And we're basically saying the security developers will update their database every week once, hence the new virus also deleted. So as a cybersecurity specialist, there are what we call safety tips. So the first tip is you should always use an antivirus software. You should insert firewalls, pop-up blockers. You should also uninstall unnecessary software. You should also constantly maintain a backup. Also, check the security settings within your systems or within your machines. You should always use a secure connection. Also, open attachments carefully and use strong passwords. Don't give your personal information unless required. So basically, these are some of the safety tips that you need to know, or that you need to always make sure that you are implementing within your systems in order to secure them from cyber crime. So in conclusion, the only system which is truly secure is one which is switched off and unplugged. So only way to be safe is pay attention and act smart.